This video will be about binary comparison using an R2 plugin, which is radiff2. If you want to verify the installed plugins, you can go to your user bin directory and run ls command to see if the required plugins is installed or not. As you see here, I have this plugins installed. If you install the other two in a true way, mostly these plugins will be installed with you with no need to reinstall any of them. You can install every plugin if you missed something using R2PM, which is the package manager of R2. Actually, here in user bin, this is just a shortcut. If you want to see where is it originally installed, you can run ls-l command, and here you can find where is it installed. On my desktop, I previously compiled some binaries from one source code, which is compared to C. These two binaries here is for x86-64 architecture, and this bin -ARM64 is compiled on Termax using GCC on my Android phone. As you know, I can't run it here as it's not suitable for this architecture, but it's does the same job of the x86 binary. So I will execute the x86 binary here. As you see, it prints two lines on the screen: hello from sub function and hello from main function. Here is the source code, which the binary is compiled from. I have two functions here. The first is sub function and prints this line here, and here is the main for sure. If you're familiar with C or C++, you should have the main function in every code you make, because without main function your program will not be executed or will not be compiled. Main function, I invoked this function, which is sub function here, and printed another line. Here in modified binary, I will execute it. As you see, it prints now a different line, which is hello from only function, and the second line is disappeared. It's obviously clear that there is a change in some string in one of these functions, and one function is stop, and for sure it will not be the main function. So to do a comparison, I will run radiff2. We have different options to run it. -C lowercase is for showing the number of changes between the two binaries. As you see, there is two changes. -C in our case Sorry for that. This error happened because I didn't add the analyze flags. Shows, as you see here, the matching and unmatching between the two binaries in functions, and here is the percentage of the matching or unmatching. If you want to directly get the match point, you can run it as given. As you see here, it printed this line only, which shows unmatch in subfunction. Dash O in our case is showing the difference in opcode. As you see here, it shows that at two places is a change, and here is the original instruction but in hex, and here is a change it as well as here. To decode that hex, you can use radiff2 as I showed before in a video. Dash A for architecture. I am in x86, and dash B for bytes, which is 64. Dash D to run the disassembler. I will decode the change here, which is C3, and as you see, it's a return line. 55 is a encoded hex of this instruction, which can mention the start of a stack in x86 assembly. So I will run now 2 with that binary. Now if I see to the first address here and on PDF, let's see that it's a sub function. If to shows that this address of a function, this will be the first address of instructions inside the function itself. Here's the instruction I mentioned when I said the start of the stack here. There is the encoded hex of it, and here is the replaced instruction, which is ret, standing for return, which is C3 in encoded hex. The other place, as you see here, is a string of hello from main function, which is changed to hello from only function. Now this is a way that can be expected for this change in binary. There is another way which I did in the binaries I compiled on my Android phone. For this time I will compare between the ARM64 binary and the modified one from the same architecture. As you see here, I have 2 points of change in opcode as well as the previous one. So I will run R2 again, but this time with the ARM64 binary. To encode these hexes, you can use radiff2 again. You can use it even inside the shell of R2 or any bash tools you installed. You can run it as normal in R2 shell. Every instruction which starts with LDR is for loading a data from data section to a specific register. This change can happen in the string we found out before, which is hello from only function, which was originally hello from main function. And the second point of change we can find nope. Nope is standing for no operation in ARM64 assembly or in x86 as well. Be done here, and this is the string which should be the change from main to only. And if I seek it to main function pf, this instruction which is bl branching to that function or calling it. And here in the same address you can find out they change it to nope, as we saw here after I disassembled this hex, which is mean this function job is stopped, and that the string that it should print, which is hello from subfunction, is stopped too. I wanted to show you something else about showing information about which architecture. I showed before that you can use file command which can show information about your binary, but you can use radiff2, which is a plugin for R2. Dash I in our case is for showing the information. Here is R, which is architecture, is R, and the bytes is 64 canaries for stack canaries, and more information like this binary is not stripped when I compiled it. The same for the x86 one. Is R is for x86 and bytes is for 64, and bin type is for binary type. Elif is executable and linking format, which is used in Android libraries and Linux libraries as well. Thanks for watching.